Hi class, let's talk about our final project, which we will use your 2D truss program to optimize a steel roof truss for snow nodes. This example exam or project, whatever you want to call it, it's going to show you how powerful it is to have your own matrix structural analysis tool. Optimization is always at the top tier of structural design. Like if you think about high-end consulting companies, that's what they do, optimization. It can be done probably through some commercial software, but if you have your own thing, you will find out it's much easier. So we're gonna do steel material. Every single one of your members, if you check their stress after analysis, it should not exceed this number, 36 KSI. Then we're using 29,000 KSI steel, and then the density, you have to use this number. Gonna do two cases. One is a balanced steel slow load, which is, you see this one is symmetric, okay, symmetric. Another one is unbalanced, which you think about some wind blowing the snow on the other side of the roof, so it's, oh boy, yeah, it's like very heavy on this side. So the configuration is that you're on top of your wall, so the supports at here and here, they are 120 feet apart. The roof surface is at 20 feet from your support, so that's given. Then the loading spot is given to you, so basically they're like equally spaced 20 feet apart. So your truss, I don't know how you're gonna draw it. How many other nodes you have, like in the middle here, how you want to do, what kind of shape, but you have to have those 7 nodes, right? Those 2 nodes gonna be your support. You're gonna fix both of them, and then those nodes you are using to apply your external load. There's a restriction that no member should be longer than 30 feet. If you do a calculation, you find out like the distance between this node and this node, it's less than 30 feet. So 30 feet, you can go from here to like almost like here. So you don't have to use 30 feet. It's just you cannot be longer than that. And use as many other nodes or other members as you want. I don't care. But here's the catch. For a roof, or anyway, for any steel structure or any structure, if you're doing a truss, we want it to be as stiff as you can, which means your deflection after you add all the nodes on this center point, node C, will be small. Then your total weight, which can be calculated by each member, you have the L, the length, you have the area A, you times those two together, times the density, then you get to your member, then you add every member together, then you got your total steel weight, okay? So the total steel weight, we want it to be small, but if you make your truss too flimsy, the deflection is gonna be huge because you don't have much stiffness. So what we're trying to do is to kind of balance those two, so we time them together to come up with what we call an index, okay? So because you're using the same truss with both case A and case B, so your total steel weight for case A and case B should be the same because you're using the exact same truss design. But the deflection is going to be different, okay? Under B and under A, the deflection will be different. So you calculate it for each case, this index, then you just add those two indexes together, you get a total index. Our objective is to minimize that total index. Whoever gets the lowest total index wins. You're like, okay, what is winning here? Up to this point in our class, as long as you are like with my help, I'm very you know, free-minded on like you know, deadlines, but I just hope you learn and everybody move forward with programming. So up to this point, as long as you finish your program, even with my help, I think you will get like at least a B for all the other homeworks, right? Because I don't take points off that easily, as long as you do your work. But for this one, it's a little bit different. It's kind of a fun one. Everybody is gonna give me your result, your final design. Then you're gonna have your index. Then I'm gonna rank order that index, and then I'm gonna switch it into like 3 tiers. The top tier will get a higher score. The middle one, okay. The bottom one, yeah. I mean, yeah, still pretty good score, but not great. Okay, and then that'll be the score for this project. So at the end of the class, I think during that week, we can have we'll have our winners by that time. We have our winners come up, and maybe like top 3 people come up to tell about their design and show it to everybody. Yeah, I think it'll be fun. This would be a good exercise. Okay, let's try that, and then yep, have fun designing and optimization.